So I sometimes feel like we don't give the culture as much. We tend to give we tend to give a lot of credit to the lone genius myth, I'd say, in the sense that here's one person who made a lot of great contributions to math and who's cracked this
Yeah.
great problem. When
Uh-huh.
in reality, they had great professors, or they had at least one good professor. They had a culture around mathematics that was positive in general and that encouraged exploration.
I totally agree with
Um,
this. Yeah. Please go ahead.
mhm. So yeah, no, please feel free to interrupt. So yeah, I just wish we celebrated people like that more, or like that this culture more,
Uh-huh.
that allows mathematicians to do what they do, or just researchers to do what they do, right? Not just Einstein in isolation, but there was also what was his name again? Yeah, the fact that I can't
Mersin.
remember his name, Grassman.
Mersin.
No, no, I'm talking about Einstein. Einstein had a friend, like his surname was
Journal?
Grassman.
No.
No,
Go
no,
ahead.
Grassman was the
Grossman.
surname.
Oh, okay. Right. Okay. I see what
Yes,
you're saying.
you probably heard of him. Yeah. So he helped Einstein a lot through the math behind general relativity, special relativity. And then there was Hilbert as well. There was the Göttingen school that helped
Hmm.
him develop his theory further. No thoughts
Right.
played a part. And yet, who we remember is Einstein. Most people remember is Einstein, not the culture around general relativity, and that led to the theory. And I wish that we celebrated the culture more.
I
Um,
definitely agree with you. You
mm,
know, it's interesting. We say Newton was so incredible, Leibniz was so incredible. Isn't it at least a little weird that they both did the same incredible thing, like almost at exactly the same time? It's like
yeah, in the same era.
calculus is an amazing accomplishment in math history. I mean, just undeniably. I mean, it's just an enormous
Hmm.
accomplishment.
Hmm.
You look at the 100 years after calculus was invented, it was all like calculus applications and stuff. It was just like
Yeah,
so,
yeah.
it spurred on so much additional math. It solved so many physics problems.
Even
Um,
philosophy.
Philosophy, yeah, I mean, yeah, exactly. Thank
Yeah.
you. So yeah, it's this amazing thing, and yet, yeah, it's so weird that it happened at almost exactly the same time. Relativity. More than one person had these ideas almost at the exact same time. It's kind of a race towards the end. Niels Abel and Évariste Galois both solved the quintic, which had been unsolved for 250 years almost at exactly the same time. Why is this? Well, it's what you're saying. It's because the you know the person who puts the finishing touch on something gets the credit. But there is so much other work that has to be done, usually, to get them to that point, right?
Mhm. Yeah,
Um,
yeah, yeah.
yeah, I mean, there's actually a pretty interesting argument that the hard part in developing calculus was not calculus; it was pre-calculus. Pre-calculus took forever for people to figure out, right? I mean, coordinate geometry and all that stuff.
Algebra, trigonometry. Yeah, yeah.
Exactly, all that stuff and analytic geometry, all this stuff.
Yes,
It
yes,
took
yes.
so long for people to find. And in hindsight, it's like, oh, it's trivial. Right? It's so easy. It's pre-calc, right? Right. We can teach it to 14-year-olds and it's fine. And you think it's so, but that took so long. Once that was done, it was just like one or two generations later, and then you have calculus. And it's like it
Hmm.
basically like that was the important ingredient to get to calculus. So it's very interesting. Uh, for Newton's credit, I agree. I like the people who collaborate a ton. I love it when the people who have this communal approach to learning and scholarship. He did say, what's his most famous quote? Um, uh, um, if I've seen farther than other men, it's by standing on the shoulders of giants. So, even
Hmm.
he does recognize that he didn't do it alone. There were giants
Yeah,
before
yeah,
him who he stood upon to
yeah,
see farther than everyone else. Um, and I agree with you. It's so much of math is this collaborative thing. And I agree. The culture should recognize it more.
yeah. I would also like to point out the fact that Archimedes was already toying around with the idea of a limit 2000 years before Newton and Leibniz came up with
Hmm.
calculus. And who knows what ideas of limits we had before Archimedes that led to
Uh-huh.
Archimedes toying with that idea of
Uh-huh.
approximating the area of a circle using infinite polygons with infinite sides.
Yeah.
Um, So I'm also
True.
curious to hear your views on modern day math culture. For example, when we see a paper, there's the title, there's the author, and then there's, the math paper. But oftentimes what you don't see in the paper are who are the people who you don't see who also wrote this paper indirectly. Perhaps this person's teachers, or perhaps the other papers that this person read, or the books that this person had, books that were written really well, that this person had access to. So I think this is one of the reasons why I'm a bit turned away from prizes that are awarded to individuals. I think it's really important to celebrate individual accomplishments, but at the same time, it's also important to ask ourselves, okay, what environment was this person in that allowed them to do such great work? And how can we create more of that environment? And sometimes I feel like when we write textbooks or when we're forming math departments or when not just math departments, any departments, and when we're writing, or I don't know, we're just designing curriculums, um, this isn't a question that we ask. How do we design a curriculum that will create good mathematicians or great thinkers?
Mm.
But what do you think? Do you think this is changing? Do you agree? Do you disagree? Um,
Um, yeah, I think so. You're asking about ways to move the culture in that direction?
do you think the culture
Should be
is
moved
not
in
there,
that.
first of all?
Yeah.
No, do you think if it's, you might think it's already there,
Okay.
or you might
Right.
think it's not?
So
So, yeah.
yeah, I mean, in papers, there was usually an introduction section which
Hmm.
cites earlier work, um, and it's usually earlier work as like the direct like stepping stones. Like here's the partial results that were discussed earlier, or here is this paper had a tool that was developed that we're going to use in this paper. So there is so the, I think research articles do typically share some of the broader culture that is that contributed to the final result. So I do think there is some of that already. Could there be more in papers? Yeah, maybe. I mean, I think it'd be a perfectly nice thing, but I don't know. I'm a little bit
Perhaps
more
not on papers today.
yeah, and it's research articles. Not like many people are. Not many people read research articles. You write a research article, and probably some of them are obviously read many times. Most of them are not read, hardly ever. Um, but nevertheless, uh, but yeah, I mean, I do in general support thinking about this stuff and giving credit to people when um, when that opportunity arises. I'm not sure the best way to sort of start implementing that in curriculum, but yeah, I like the idea of thinking about it. So, a related thing, so like in the history book I wrote, after every chapter, I have this section called A People's History. And
Hmm.
it's related to these ideas. So a people's history, that phrase is used in many different contexts in academia and literature and stuff. One use of it is by, it's up here somewhere. There's a book called A People's History of Science. Uh,
Hmm.
yeah, this one. So there was a book called A People's History. This was A People's History of Science. So the first People's History notable book was this book, A People's History of the United States, and it just sort of said, well, the history of the presidents, the leaders of the United States has been told many times over. This is a book on the history of quote the people. So just like an ordinary people
Ah,
living in Philadelphia, you're not the governor, you're not the president, you never signed the Declaration of Independence. What was your life like? So it's just sort of that's the story of those people. And then, but another way this phrase has been used, for example, in this book, is examples of how science was developed by the people. So not by, elite scientists at institutions who are paid to be professional scientists, and they publish their work and stuff. Other people contributed to science, but they never thought about themselves as scientists. So midwives contributed to our understanding of of anatomy and medicine because there was a need, right? Babies had to be born, so they figured things out. Um,
Yeah, yeah, yeah.
People who worked with metal discovered stuff about chemistry because they needed it to do their job well. Um, and people who farmed figure out botany and they're farming, maybe they have livestock. They develop they learn things about genetics in doing this. So it's just a bunch of interesting examples of that. So some of these people's histories sections in my book are about this sort of thing. People who would never have thought about themselves as mathematicians developing math because they needed it to do, like the first one's a people's history of numbers. There's interesting history. Where did numbers come from first? There's a, it's you have to, it's history. It's not, you have to look at records to sort of make your best guess. But there's a reasonable, pretty good argument that it was by ordinary people who were just small business owners, merchants who needed numbers in order to do their to run their business. Next on people's history of trigonometry, and after that, surveying. So people maybe would need to survey land, right, in order to, like in ancient Egypt, the Nile floods people's where people live, their plots of land, pretty regularly. About once a year, the Nile flooded, and people had to pay taxes to the pharaoh. And
Hmm.
I'm sorry.
No, no, I'm
Oh,
just
yeah.
nothing.
So
Carry on.
and but if their part of the land got washed away, and they lost 20% of the land, then they would have to pay 20% fewer taxes. Okay, because
Mhm.
everyone was given an equal amount of land. Um,
Right, right.
so anyway, so these surveyors would come and survey the land, and they'd have to use geometry, right? So they'd have to figure out geometry uh, in order to measure these things. And there's other interesting things. People who were doing so some military commanders had to figure out, like, if you have a river and you're standing on one side of the river, and maybe there's a tree or something right on the other bank, and you want to know what is the distance between me and that tree. How do you figure this out without crossing the river? You can't throw a rope across it. It's a big, fast moving river. You can't enter the river. How do you figure this out? There was a really cool way that they did it using triangles. And these are things which, it's not a mathematician most likely figured this out. It's just somebody who needed to figure it out. And anyways, so so these are things which kind of get at the same idea of math coming about from many people working together in some way to accomplish a goal. Less so from the one person who does it and then puts their name on it and publishes it and gets credit forever. So, anyways, adding to the discussion.
Yeah. Um, I think a good analogy would be trying to think of it like a puzzle, but thinking of it, but the pieces are like 1,000 pieces,
Mm.
and that even though some are larger than the others, the size isn't, I don't know if that analogy works here. It's like everybody contributing some piece of the puzzle, or perhaps in chemistry, how they have this concept of activation energy, how there's a
Uh-huh.
barrier, and once you cross that barrier, then the bond will break or the bond will form. For
Ah,
example, the activation energy required to start a reaction is 10
right,
joules.
right.
So you slowly feed the system energy, and the
Uh-huh.
energy rises. And the second it hits 10
Uh-huh.
joules, the reaction occurs.
Yeah, yeah.
I don't know, those analogies spring to mind when we're
Yeah,
talking about
that's
this stuff.
good. Yeah. Whatever that final jewel was, or tenth of a jewel, gets the credit for making the reaction happen. But there was other energy went into it before you noticed any change happening, right? All the
Yeah,
pre-calculus
yeah.
happened, a lot of energy was happening, a lot of things were added to calculus, but someone had to be the one who does it in the end, who makes the final reaction happen.
Yeah,
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 that's true. Even in computing. So the final people's history talks about, like, these computing collectives. So when people, like the first computers, um, and sort of people writing code, were I'm figuring out a quick way to say it, but there were these like
Hmm.
groups of people in like Minnesota was one big collective, Boston was another one, San Francisco a little bit, who were like who were developing so there'd be like one computer for the district, and people could have computing time, and they would make design
Yeah.
games. There'd be like there was like an early football game. There was an early you could play like solitaire or something. There were little card games. You could do like basic forms of email, and it was sharing the computer. Well, how do you share a computer? Well, you'd have to use some interesting coding to do that. So lots of people worked together to in this collective computing way. And for that for these it's very clear how many people contributed because it's every because this is I guess unlike the your chemistry example because it was every little bit I'm going to do this little thing over here and now it's part of the mainframe, right? It's on the system, and now other people can use it. Well, I'm going to do this other little thing, and so many people contributed to this early development of coding, which of course today is runs the world.